All right, everybody, welcome back once again. It's the Dr. Seifrit and Don podcast. It's Friday, February 24th, 2023. I'm Don Seifrit. I'm here with Dr. Kari Peter. Say hi, Kari.
Hello.
I'm here once again with Johanny Castro. Say hi, Johanny.
Hello.
So we had Johanny on about a year ago for season 3, episode 1, and this is season 4, episode 1. So we've come full circle on that one. And we also have a special guest. We, over the next couple weeks, are going to be starting a series on post-harvest rots, and we're going to have a number of pathologists on. And we have with us today Dr. Wayne Jurick from USDA Beltsville. Say hi, Wayne.
Hello.
So, Wayne, before we get into the meat of this, if you could introduce yourself and tell us a little bit about yourself so folks can get to know you, that would be great.
Sure. I'm originally from Florida, a native. I got my graduate degrees from University of Florida. Did a couple of postdocs. One of them landed me up here and got into the post-harvest world. Really interested in blue mold, gray mold, bitter rot control. Almost all exclusively post-harvest. Do a lot of fundamental biology, but also am interested in practical question-based research that will help the producers. So, and Kari was my first postdoc. So,
well, thanks for joining us, and we're really excited to have you and your lab on in the next couple weeks to do these episodes and teach the growers that listen to the podcast about what you guys do. So thanks for joining us today.
Thank you.
All right, so let's roll into it. Johanny, you're kind of the star of the show today. So for folks who didn't listen to your last episode, could you give us kind of a brief summary of what you talked about and your previous research?
Okay, so first, I think it is interesting always to know why I started working with post-harvest diseases with apples. Part of my master's degree in Costa Rica, I am originally from Costa Rica, was on pineapple diseases, specifically with penicillin, which is a very common pathogen in apples too. So that was the first connection with apples, since my interest was to continue studying a pathogen that is similar, that in some way I can use that knowledge in other crops if in the future I'm working with something else. And also to help growers, so that I can use part of my experience to help growers here in the Mid-Atlantic. So that was the perfect connection to start working with that. Then when I came to Penn State, one of the questions that I asked Dr. Peter and later to growers, and I think those questions are also important in any system that you're working with, is what pathogens are causing disease here, what post-harvest pathogens, what are the sources of those pathogens? And by sources, we're talking about where can we find the spores, beans, picking bags, different sources. Third, what is the situation of fungicide resistance, which is also very important because there is a limited number of fungicides in the market right now for growers. And finally, what management strategies are they using? So I think those 4 questions are very important in terms of the end goal that is management. We found that there's information, there was some previous research about what diseases were here present, and there's information about inoculum sources, but most of that information comes from other states, like Washington, for example, information in New York. Then we found the gap in knowledge here in terms of knowing first, what is the frequency of the pathogens that are causing disease? They have the same frequency in all the packing houses in the Mid-Atlantic, or is there any difference in between large and small operations? And there was also information about fungicide resistance. So fungicide resistance was previously reported, especially for penicillin, the pathogen that causes blue mold. But the same situation, what is the frequency of those isolates? Where are they coming from? Those were still questions that we wanted to study. And finally, they basically rely on chemicals, fungicides for management. There's a couple of options that they have, a couple of fungicides, Scholar, fludeoxonil, and Tembotec, pyrimethamine. But certainly there's a limited number of molecules that they can use, and then we wanted to explore more options so that growers can have more tools to manage diseases.
Cool. I mean, I think those are all super great questions, questions that I'm sure the growers pitch to you and are happy that you were answering. So if you could maybe give a brief summary on what the inoculum source looked like in the Mid-Atlantic versus some of that other data, was there a difference when you explored that?
Okay, in terms of inoculum sources, we certainly have similar inoculum sources. Actually, the inoculum sources that we defined as part of our study were based on the literature. What is maybe different is the categorization of those inoculum sources. Maybe, for example, beans are reported to be a very good inoculum source in other states. We wanted to see if that's the same situation here. For a pathogen like penicillium, for example, we're going to find it everywhere because penicillium is basically wherever you look. But what we were looking for is, okay, is there any way to categorize so that you can target management by going to the inoculum sources that are more important first, and then you evaluate if that's working or not against your diseases. So just to summarize what inoculum sources we are talking about. So we went to the packing houses and the orchards, and we selected different post-harvest inoculum sources. We selected picking bags. We selected the bins. We selected the water of the dump tanks in the packing houses. We also sampled the surface of the apples before and after harvest and after a long period of storage to see if we find the pathogens on the surface of those apples and if there's any change with storage. And we also sampled the air of the packing houses and cold rooms. Those were the sources that we thought we could find more pathogens. And then we started extracting or isolating the fungi present using different laboratory techniques that we're not going to explain in detail right now, especially because we talked about a little before. But in general, that's field work in terms of the sampling and lab work in terms of going to isolate the pathogens, start growing in culture media, and identify those pathogens by molecular methods and also morphological methods. And that's how we came up with some information about what inoculum sources are more important for this region specifically.
Yeah, thanks for that clarification. For folks who maybe didn't listen to that last episode or, are unfamiliar with you and some of your work, I think that's super helpful. So appreciate that. How did some of that research progress? Like, what are you looking at right now? What are you working on right now?
Okay, right now we are kind of working on three main things. One is to finish getting the species that are causing disease. So I think last year we talked about three main species that are present here. Last year we talked about the genus, Penicillium, Alternaria, and Phlectema or Neofabria, which is, all those are common pathogens on apples. Now we are trying to sequence different genes in order to get more information about the species. Getting to species is every time more and more difficult because of more information about molecular and identification and so on. So now we have more information about that. For example, we found that Penicillium expansum is the most frequent pathogen here in the Mid-Atlantic. That's not surprising. The previous research has shown that in many different states and countries. We also found that Alternaria is very difficult to identify. Now we have Alternaria, it's probably Alternaria alternata, but we're still working on that in terms of molecular. We have sequenced almost 5 genes, and we are getting closer to the identification. And the other pathogen that is here is Phlectema vagabunda or Neofabria vagamunda. You're going to find both names in the literature, and the disease that is causing is bullseye rot. Many growers probably know more by the name of the disease. And those are the three main diseases that we find here and that we are using for all the rest of the research that we are doing, especially with the management strategies.
So with these 3 diseases showing up on apples, I mean, you had mentioned Penicillium expansum is really the predominant spore that you find in storage.
Correct.
But these Alternaria spores and Phlectema spores, these diseases you aren't finding these in high numbers in the storage, but these diseases are actually starting out in the field and then showing up in storage, correct?
Exactly.
So I think that needs to, as far as explaining, because what's interesting with your research is that there's really two stories going on. You've got the situation going on in storage, as far as what spores are showing up, which is your typical blue mold spore, which is extraordinarily important. But then you've got this other excitement that's happening, but it's actually starting before storage. It's actually starting out in the field.
Exactly. That's something very interesting that we found with this research. Originally, we were thinking about penicillium as the first pathogen because that's what is reported in many countries and states. Penicillium is the main post-harvest disease almost everywhere. We found something different here in terms of the frequency. Certainly, penicillium is present. It is still important, and you're going to find and hear about that in future podcasts about how important is penicillium, especially from a mycotoxins perspective. So we have that fungus at about 14% frequency here, so that's important. But we have a system where penicillium is mostly post-harvest. We're finding that the spores of the pathogens mostly in cold rooms, packing house environments. So that means the fungus is infecting the apples after harvest. Then we have a second pathogen that is Alternaria. Alternaria is even more challenging because Alternaria can come from the field. We have found spores on the apple surface at harvest. That means it is there in the orchard. But we have also found spores of Alternaria in the cold rooms and also in the bins and almost everywhere. If we compare the frequency of Alternaria with penicillium, it is less frequent, certainly, and the number of spores is lower, but it is there. So it's just waiting for some injury or some other problem to get advantage of that. Then for Alternaria, we should focus both post-harvest and pre-harvest. So that's why it is more challenging. And the third pathogen or third system that we are looking at is bullseye rot or Neofabria flectema that according to previous research in other states, it is infecting any time from bloom to harvest. So that means the fungus is basically in the field. It is infecting. The growers cannot see the symptoms when they harvest the apples. And it requires around 3-4 months in storage so that you can actually see the symptoms. So that's why management here in the Mid-Atlantic is so challenging because you have systems that are quite different and you have to start being careful in the field, but also in post-harvest if you want to get full control of that disease.
So one of the things you said, I believe it was for the Alternaria, that it was waiting for like an injury to occur. Let's say I have an apple and it's sitting in the middle of a pack house floor in a big empty room and I just leave it there. Would these diseases not infect that unless I came in and like took a cut out of it?
That's a very important question because we have different pathogens in Alternaria and penicillium. Both are very similar in that sense. They usually take advantage of injuries or any other opening that they can find to cause disease. That's what has been found earlier. Then, in this case, things like a chilling injury or cold problems with cold storage. If you store your apples at lower temperature or if you cause injuries during harvest or post-harvest handling, that's going to open wounds or the entrance for that pathogen. As an observation that I have seen in the packing houses is sometimes you find a problem that is very common on apples, that is bitter pit. It's kind of a physiological disorder associated with calcium, problems of calcium. And sometimes you find the pathogen there. You have the infection, but you can see that the original problem was probably the physiological injury and not the pathogen just came later and caused the problem.
Gotcha. So it doesn't necessarily have to be mechanical injury. It can be like a physiological injury to cause these as an infection.
That's what I have seen in some apples. Yeah, there's another physiological injury that is called soft scald, and that it looks very similar to what is a rot. And sometimes the pathogen comes later and just infects, but the original symptom was something else.
Gotcha. I appreciate that clarification.
Hey, Johanny, I had a question. You said Penicillium expansum, Alternaria, most likely Alternata, and Neofabria or Phyllectema vagabunda. So the first two are important for losses, but they're also toxigenic. And then the third one is bullseye rot. So aside from the economic consequences, of loss and toxins. If you're producing fruit, why else would you be worried about some of these pathogens from, say, from a more international perspective?
Maybe you're talking about, for example, quarantine pathogens. In this case, Flectema is a pathogen that is a quarantine pathogen in some countries in Asia and also the Middle East. Even though Pennsylvania is not exporting lots of apples as it happens with Washington, but there are some growers that export. So that's actually very important for growers that are exporting, and then management becomes even more important in research that can help them to cope with that problem.
I think for Pennsylvania, Mid-Atlantic isn't the biggest export to Mexico. I think it's Mexico is the biggest, and then I think India, is another one. But yeah, so that I think trade block, I think with the Neofabria or the Phylictema, whatever they decide to name it, the bullseye rot. The other question was, are any of your alternaria isolates, have you found any of them have potential to produce toxins? Do you know if they have any toxin producing capacity?
Okay, with alternaria, well, that's not part of the objectives of this work, but certainly what we are finding is probably mostly alternata. And if you go back to the literature and read about that fungus, it is able to cause or to produce many mycotoxins. And even though some of them are not officially regulated, but there's literature saying that that fungus caused that.
Nice. I know it's also I think it's considered the number one indoor allergen, Alternaria alternata. So even in households, there's a lot of work from allergists. Even if you see an allergist, one of the things they'll give you is a booster. Allergy shots a lot of times have Alternaria in the serum, but it's one of the most common indoor air contaminants. So it doesn't surprise me that you're finding it. I think penicillium hangs out inside commercial houses even. So it doesn't surprise me that you're finding those two in abundance in your air samples. It's a very curious trifecta there that you have to work on.
Johanny, have you seen co-infections in the fruit, as far as, Alternaria and penicillium together, as in, it looks like they're sharing the same rot spot? I'm just curious as far as the risk of one rot creating an entry point for another pathogen like blue mold, because we're not going to get into the weeds about it here, but we'll get into the weeds about it in future episodes. But, you briefly mentioned that blue mold, the penicillium fungus, Penicillium expansum, which is the dominant blue mold, produces the mycotoxin patulin. And so, we've noticed, with some growers that when they have some fruit going into storage, they may have an unknowing rot infection that is dormant that comes up occurring in storage, only for it to become an entry point, a wound entry point for blue mold. Because as you've mentioned, blue molds, the spores are quite dominant in the cold storage. So it sounds like we know that blue mold has the potential of taking over these wounds. And so consequently, you can have blue mold co-infections, I guess, of blue mold on the fruit, which then in turn can threaten growers who may be using that fruit for processing, because processed fruit is it's regulated for patulin. And so there are thresholds that aren't to be exceeded. So I'm just curious as far as, we've got these 3 different pathogens that are dominating the cold storage or dominating the rotten fruit coming out of cold storage. I'm just wondering, is one more aggressive than the other? Do you see in your collections, have you seen co-infections on the same fruit? This is more of a curiosity perspective that someone may be, wondering about, okay, if I have a fruit, do I just have to worry about the one infection, or could I actually have multiple infections? Could the same infection have the same rot spot have, multiple infections?
Yeah, about that, I think we found 2 different things. First is it's not the most frequent thing that you are going to find two infections in the same apple. We didn't have that very commonly, but it happens. So you can find that sometimes. And Sometimes Alternaria and Penicillium were found in the same infection. My question there was, okay, who came first, Penicillium or Alternaria? Then what we did was to take a few of those apples and go to the lab and get segments of the margin of the lesion. And then what we found is that even though Alternaria is there, Penicillium was the first causing that infection. So that says that Alternaria is probably taking advantage of that infection to go and cause, and that they are not incompatible, that both can grow almost in the same lesion. That's one situation. With bitter rot, that is the other, that you might find some lesions. I would say just one or two apples with that situation where Penicillium was there growing, but I wouldn't say that was very frequent at all. And the third situation that we found with that is that sometimes you isolate from the margin of the lesion and you find, what we do is to get 5 or 10 segments of that lesion so that we can kind of have a statistical analysis of what is more frequent. Then you find, let's say if you have 5 segments, you find 4 segments with Alternaria, and in some cases you find a second pathogen there that is present, but just 1 segment or 2. That gives an idea of what is the pathogen that is more important or that is causing the lesion and what is the other, even though the original symptom looks like Alternaria. So I would say that Alternaria is one of the most interesting because it seems to be compatible with many other organisms. That's what I have observed in my collections and samples.
I just out of curiosity, I mean, that's really fascinating because it seems that is almost a survival mechanism for Alternaria to be able to coexist with other pathogens. And I'm wondering is, just out of curiosity, because I don't know the answer to this, if you've looked in the literature to see if Alternaria has behaved similarly in other systems. I mean, because Alternaria is quite ubiquitous. So I'm just curious, like in another cropping system, has there been noted co-infections of Alternaria and something else? Just out of curiosity.
I tried looking in the literature to see if there's some information about co-infections. Maybe I have to look with more detail, but I didn't find specific studies or reports about that situation very frequently. To be honest, I don't remember. Maybe 1 or 2 papers saying something similar with other pathogens, not necessarily with Alternaria. But I'm sure there are reports about, not specifically maybe Alternaria, but other pathogens. That's a situation that can occur. But probably what is not there is specific studies looking at that.
I think there's quite a bit of work from Pete Timmer from on citrus with Alternaria and other infections. So you might want to scour the citrus literature to look and see. I'm trying to think of any other pathosystems that would be, cabbage comes to mind, but that's a Brassicula. That's a different species. But I think citrus might be your best bet to look at for co-infections because, they get so many other things in Florida, but I know that Alternaria is quite a bit of a problem. Megan Dudney works on that issue now somewhat. So I had a question about, so your findings with your inoculum sources. I think you showed this, that, if somebody's got a pack house, that there's certain areas to look at. So what is there any suggestion on what to do about this now? Or do you need to do more research to see what the abatement strategies would be? But what would you plan to do to translate the information you found? That you've got all this good information. So how do you plan to take it the next step?
I think we can start talking about, for example, the air quality of the cold rooms and packing houses. So that was the main source of Penicillium, and we also found Alternaria. So I think growers should, if we categorize sources, those would be the first point where they should go. And in some interviews with the visits, some of them are doing some disinfection. Some of them are not disinfecting their cold rooms because of their operation, or there are many reasons that can justify why they are not doing it. And the first thing would be to look for alternatives to disinfect, especially cold rooms where you cannot empty those cold rooms because your operation requires having apples almost all year. That's difficult because you cannot apply almost any treatment. What options do they have? Well, if I'm not wrong, there are some options with peracetic acid. You can fog your cold rooms, and the fogging is a strategy that can help. That's certainly not going to eliminate 100% of what you have there, but it's going to reduce the populations of the pathogens that you have there. That would be a short-term strategy if you have a problem. You first need to know if you have a problem. I would say go sample your cold rooms and see if there are really pathogens, because we sampled 10 packing houses. We can certainly have more than that, and maybe not all have the same problem. Then that's important if you're going to invest in that strategy. The second is we also found very, very interesting results with the dump tank water, especially when you process apples after 6 or 7 months storage. And we found that the chlorine levels are very low in most packing houses. Practically those chlorine levels are not doing anything. There are some reasons for that. Some growers are thinking about the equipment. There are many reasons why they are not getting very high levels of chlorine. That opens the question, okay, should we focus on that, on just increasing the chlorine levels, or to look for another disinfectant or another method that can be incorporated to get rid of those pathogens? And they have to do it anyway because there are foodborne pathogens that are also important. So you need to work on both systems, and I think more research is needed to see what else can they do. If they don't want to use chlorination, what else we can come up with.
Yeah.
And but right now that would be the short-term strategy, just to increase the chlorine levels. And finally, there's some research, especially in other countries, about air cleaning or air disinfection, how to filtrate spores and how to use some chemicals, especially ozone. But there are some companies that are working on a more integrated approach to get rid of not only pathogens, but also ethylene. That is another problem from a physiological perspective. Then I would say research in that field is also important to, especially for growers that cannot empty the rooms, that they cannot treat the rooms. Finding a way to filter the air and getting rid of the spores and ethylene would be very important. Why that research is so difficult? It is sometimes because it is expensive. Those equipments are not cheap. They have to invest a lot of money. And in order to test that, you have to do it probably in a packing house is the best way to do it. Getting a cold room, getting the equipment installed, and see what is the effect on post-harvest rots, on foodborne pathogens, ethylene. So it's more like an integrated kind of project that requires quite a lot of money. But once you get good results with that and you have your equipment, that's going to last for years. So the investment is probably very good, but I would say that's something for the future.
Nice.
I was actually thinking I was going to ask you if anyone or any company, something like that, is looking at maybe the installation of something like a HEPA filter into a pack house environment. You know, HEPA filters catch things like black mold and that sort of thing. So I was curious if that would have any validity in some of the work that you're doing, or if it would be adjacent to the work you're doing at least.
What I have seen in the literature with that is that filtering is usually not the best option. It certainly works, but at some point you get too many spores. So it's not killing the spores, it's just filtering the spore. And you have to be always changing the filters, and it's a complication from a management perspective, not necessarily that it doesn't work. I would say we can take advantage of the experience in the medicine sector. They have to filter to a different level because of, for example, operating rooms and that. So that technology is there. The thing is, it is expensive. And how can we adapt that technology to our systems? That's probably going to take some time, but certainly more research is needed in that area to see if that works or not, at least to have data.
Cool. Yeah, I appreciate it.
I like it. It gives me another idea. We need to think about it like you would insects, so attract and kill. So if you had a filtration capability, but then you had, let's say, for intellectual property rights here, some way to zap those spores on either side, intake and outtake, I think you'd have a really nice system there. Cost I can't tell you about, but I have an idea. So this is good. I'll be quiet since I don't want to incriminate us.
This could be fully outside the scope of your work, and if it is, just tell me that. But is there any difference when it comes to infection in controlled atmosphere room besides just cold storage? Are these post-harvest rots still a problem in CA storage?
Okay, that's a very interesting question. We have found no differences between packing houses that use cold storage versus controlled atmosphere. And there's also literature talking about things like penicillium growing at very high levels of carbon dioxide and low temperature. And then at least the evidence that we have here for this region, it says that there's no difference for those pathogens. So we have found, for example, bullseye rot in packing houses that have CA rooms. And I would say from my data, there's no difference so far.
And well, maybe to back it up even further for people who are listening who may not know what controlled atmosphere is. So, the beauty of apples is that, one, you can store them in the cold and they can be kept a long time. But controlled atmosphere takes it a step further. So what controlled atmosphere does is that you have a cold room that's set at a really low temperature. It's usually just like above freezing. High humidity in order to keep that temperature. Then you adjust the carbon dioxide and oxygen, and you create this stasis in the cold room. And so what that does is that slows down the maturity of the fruit. So it kind of stops it in its tracks. And so consequently, you can store fruit for months and months at a time. And when you pull them out of CA, it's like you just put them in there as far as fruit for taste and quality wise. So for folks who may not be familiar with the term CA or controlled atmosphere, that's what controlled atmosphere storage is.
Thanks. I feel like I'm usually the one asking you to clarify, but that's a nice change in role. Awesome. Thank you.
Okay, Johanny, so we've talked a lot about the spore sources and what's out there. One thing that we haven't really dove into the weeds about is management. And as far as management recommendations, management issues, management suggestions, particularly for protecting the fruit. We've kind of touched on what we could do in the cold storages, speculating of options there, but we haven't really dove into a discussion about how growers can protect their fruit from these diseases. So what's your research telling us these days?
Okay, just to summarize some of the things that we've been talking and maybe growers can use or some help for their management. First is, since we have 3 different systems, I think management should start in the field, and the last cover sprays would be the first point where they have to look. Obviously, they have to look at the whole spray program, but there's lots of research saying that especially 2 or 3 weeks before harvest is a critical point because the apples are right at the point of maturity where the pathogens start getting advantage of that. So I would say those last sprays are very important. That's why we are looking also at alternatives like biological control that we may include in those last sprays, and that could help with some of those pathogens. And we are also looking at fungicide resistance to see if the fungicides that they are using currently are able to control effectively, especially Alternaria and bullseye rot, and why we have so frequently those pathogens in post-harvest. Is it because the fungicides are not working, or that's something that we are still working on? But for now, if I am a grower, I would be being careful of getting those last cover sprays at the right time so that you are using your tools. Then second, during harvest, avoid wounds and injuries, and during post-harvest handling. We talked about Alternaria and penicillium, and that's something that it is always there, but it's never And it is always important to remember that avoiding wounds and those problems is critical for those pathogens. And we already talked about cleaning the packing house cold rooms and the water. And finally, I would say something that is out of our field, especially plant pathology, but it would be good to look into the storage conditions that they are using, especially for growers that have a limited number of cold rooms and have different varieties. Some varieties like Honeycrisps require certain different conditions in terms of cold storage, and to see if that is also helping with some diseases or causing previous injuries that the pathogens are taking advantage for that. That would be also important. And I don't know if I am forgetting something, but I think those are.
I'm not sure if you've gone into it because we've covered a lot of topics. How prevalent is fungicide resistance among the populations or among the pathogens, I should say, that you're pulling out from the cold storage from apples?
Okay.
You mentioned there's 3 commonly used chemistries. And so, I kind of know what the situation is, but as far as updating people, just really what is the risk of fungicide resistance?
Okay, we have different results depending on what pathogen we are talking about. For penicillium, we tested 3 molecules. One is thiabendazole, pyrimethamine, and fluoxanil. And based on previous literature, we did some laboratory experiments where you just kind of have a discriminatory dose that tells you if your isolates are or not fungicide resistant. And what we found is that there is a high percentage of those isolates that are growing on those concentrations, especially for thiabendazole is around 40%, and for fluoxanil and pyrimethamine, we have 50% for pyrimethamine and 16% of isolates for fluoxanil. That means there is a presence of fungicide resistance, at least according to our lab results.
That was 16% for fluoxanil, correct?
16% for
60 or 16, 16 or 60?
16.
16. Okay, 16. Mm-hmm. Okay, and then for folks listening, and for those of you who don't speak active ingredients, fluoxanil is the Scholar fungicide, pyrimethamine is Penbotech, and thiabendazole is Myrtec.
Correct. What is interesting about that is we also inoculated apples with the pathogen and treated those apples with the fungicides. And it seems like the fungicides are still working against those pathogens. So that means we have resistance that is developing probably in those isolates in the packing house, but it is still not what we call practical resistance. There's a difference between what you get in the lab, which is important because it creates a warning for growers. Okay, something is happening. Both fungicides are still working, but at some point they can get problems with fungicide resistance. And for Alternaria, we found also some isolates growing on those fungicides. And when you inoculate apples and treat the apples with those fungicides, they are able to cause infection. That means for Alternaria, we have fungicide resistance in the lab, but we have also practical resistance. So it's a little different from what we found with penicillium. And with bullseye rot, we found a similar situation. We found isolates that are growing in the lab, and it grow almost, when you compare to the control, they grow almost the same when you apply the fungicide at the labeled rate. So that means we have that's why this is so challenging for growers, because we have 3 systems that are behaving kind of different in the fungicide resistance, sometimes in the lab, but also as a practical resistance problem.
Do you have any pathogens, whether it's Alternaria or Penicillium or the Flectema /Neofibrea, that are resistant to, like you've got one isolate that's resistant to multiple fungicides? Have you seen that? Because I'm sure some people might be asking, like, what are the chances of basically creating fungi that could have multi-drug resistance. Have you seen that in any of your like in vitro work, the lab work?
Yes, from my results, what I remember is for Penicillium and Alternaria, I'm not 100% sure for Nymphobria, but yes, some of those isolates are able to grow on both fungicides. The difference is how much they grow. Sometimes you find a pathogen that is able to grow on both, but when you compare to the control, one of them, and I'm going to give one example, fludioxonil with Flectema or Nymphobria, you get the isolate growing on fludioxonil almost the same as the control. And on pyrimethamine, you have the isolate growing, but no more than 10-15% of the control. That means the fungicide is reducing growth, is stopping a little bit the growth, but not 100%. So the isolate is still able to grow. So there are some differences too in terms of that.
All right, very interesting. As we're sitting here and as we're talking, a lot of the things that are being discussed, I'm like, ooh, that could be a research project. Ooh, that could be a research project.
One question. So what I think you're saying is that with the penicillium, the isolates are shifting away from baseline. So they're not normal anymore, but they're not able to overcome fungicide treatment when you use a formulation. So my question is, what labeled rate are you using when you test these things? Because, for example, with Scholar, it's 8 to 16 fluid ounces per 100 gallons. So what I found is a long time ago when I did this, and I found some isolates, I was testing at the lower rate, and I was able to get them to fail with product. But, it just depends on what people are using. So what rate did you test? Did you test the low, the mid, the high? And do you see differences there?
For those experiments, I think that's a very important question. We tested the maximum label rate. That's the only one that we tested for practical purposes. But yeah, certainly we could investigate more in the future what you're saying, maybe middle, lower rate and see what's going on.
And the only reason why I did that is because when Richard Kim was working at Pace and, they did a lot of stuff with Pembotech, I asked him, what were the rates that they were using out in the West Coast? And, they tend to go middle to low. This is a little bit older information, but what he told me was 10 to 12 fluid ounces per 100 gallons. So when I thought about that, I was like, okay, so maybe I need to test different rates. But I think you're right as far as potential maximum amount. But if somebody's trying to pinch pennies but still follow the label, you could get caught off guard if you go down to 8, for example. For Academy, which we haven't talked about, Academy is fludioxonil and difenoconazole. That's got one rate at 16 fluid ounces per 100 gallon. So there's no wiggle on that one. And I forget what it is for thiabendazole, for Murtec, and for Pembotech. But I think it's interesting information. We found something is definitely developing here. And it confirms what I've seen from a long time ago, which was different, more limited scope. But anyway, yeah, interesting findings.
And it also should be noted, especially for folks who aren't familiar with, packers that may use post-harvest fungicides, is that many of them are aware of this resistant issue, and so they will rotate chemistries. So one year they may use Scholar, fludioxonil. The next year they may use Pembotech or the pyrimethamine. And then also from my experience is that all apples aren't treated. They spot treat them. And then one thing we haven't talked about is administration. How do they administer the fungicide? And in the majority of these cases, the rooms are fogged. So they'll close up the CA rooms because typically these are held in a controlled atmosphere rooms. And then there's a machine that will fog in the fungicide. So it creates a, fog in the room. And so that's how fungicides is administered, as opposed to your typical drenching where you dump a liquid on the bin of fruit and coat them that way. That's not as, I think that's still used, but because of food safety issues with that method, I think that many packers are getting away from that. So just to sort of to clarify that, in these situations, we are finding fungicide resistance, or say Johanny's finding fungicide resistance, fungicide resistance management. We talk about it ad nauseum as far as what we do during the season, rotating active ingredients, spraying by the frac group numbers. The same rules apply to post-harvest too. So it's just for folks to be mindful who do use them. Is, right now, Scholar is the strongest chemical because that does seem to really suppress a lot of different pathogens, but you don't want to exhaust it by using it year to year to year.
Well, we're getting a little long in the teeth here. We're edging up on our 1 hour mark. Not that this wasn't awesome conversation and discussion, and I really want to thank you, Johanny, for coming on and doing this, and Wayne for joining us for your first episode, and we're looking forward to having you and your postdocs on in the next couple weeks.
Thank you. Yeah, it was fun.
Good.
So yeah, we covered a lot of territory today. So just as a recap, Johanny, reviewed sort of his information about where the spore sources, what they are, and really the take-home message there, it's the cold rooms, right, Johanny? It's and dump tanks occasionally, they can be, and that's a whole other topic. In the mid-Atlantic, we are seeing differences of what's coming out of storages compared to other parts of the world, especially the West Coast, is that, blue mold is the most important post-harvest pathogen as far as pathogen that wreaks havoc post-harvest. But we have these other pathogens, Alternaria and Flectemma, that can start in the field. Even though Alternaria, we are seeing it in the storage, but it does have a place in the field as well. So that creates added challenges, and especially for growers to be mindful of those fungicide sprays during the season, and as well as what they're applying right before harvest. Being mindful of your harvest, and so the fruit are going into the best shape possible into storage. And, as far as, fungicides, the problems that we see pre-harvest, i.e. fungicide resistance, that can also manifest post-harvest too. So, we've covered a lot of terrain today as far as, post-harvest apple diseases and their management. And so, in our coming episodes, we're going to be drilling down a bit more deep into some of these topics, mainly as far as the blue mold and the mycotoxin topic. So that's going to be one of the episodes. So we'll be hearing a lot more about that. Those are my final comments. And Don, any words for posterity?
Like I said, I really appreciate everyone being on here today. I know we've had a long winter meeting season. This kind of comes at the tail end of those. Kari, I think there's 3 more next week? Thank
you for bringing that up. We have 3 more Pennsylvania meetings, winter fruit schools next week, even though it doesn't feel like winter these days. We have the Appalachian region, which will be held in Altoona, Pennsylvania on Tuesday. On Wednesday, we have the Erie County meeting, which will be held in Northeast Pennsylvania, as in the town, Northeast. That's at the Birch Farm Markets there. And then on the very last day, that will be on March 2nd. That is on next Thursday. That is the Pittsburgh region meeting, and that will be held at Sorgel's Orchards. So this is all online, and maybe Don link.
I'll put it in the podcast notes.
Yeah, put in the podcast link. So hopefully any folks listening will be there. You'll get some good core credits and category credits for your pesticide applicator license.
Once again, thank you, Wayne. Thank you, Johanny, for being here today. And we look forward to having you guys on as we kind of continue this post-harvest rot series in the coming weeks. So say goodbye, everybody.
See you later. Thanks for listening.
Thank you.